Welcome to Kittyloaf Plays. Today I'm playing Kerbol Space Program 1. Project Cat Tree aims to put a habitable station near every planet in the Kerbol system. On our last segment, we launched the space station Pawprint 1 into low carbon orbit. And it's there as a crew layover point and a fuel depot for future missions. We have a second copy of that station earmarked to be launched in Minmus, but before we do that, let's launch our Kerbin survey satellite into polar orbit. And we will put a similar satellite in orbit around the Mun. So, that's a good probe core to start with. This has most of the features, also has a decent gyro in it, and actually an okay battery in it. So, we're going to want more batteries because transmitting data can get expensive, and we want to recycle this design, but we don't need the other features of this core. So what science do we want? Well, how about all of it? Now, some of these can only be run once, like the materials and the goo. You can reset them if you have a scientist on board. We don't, and we're probably not going to, so just do this as a one-off. There are some experiments that we could fit on this. I've done the absolutely everything science craft, but things like the telescope is pretty big. So I'm going to keep this modest. Put that up there. Materials. Alright, so this we can do in space. This we can only do on the ground, so that's not useful to us. I've never really found a use for the narrowband scanner. This will tell you where the minerals are. And the atmospheric pressure scanner is not much use when you don't have an atmosphere. Some of these do have some weight. These are negligible, but this is non-negligible, so you can do one on each side to balance it out. Right, low and high orbit are ones that are useful to do with that. Likewise, if we had low and high orbit materials science, but I'm not going to bother with that. This thing here. Rovers are cool, but I always find it's a real pain to put the scan arms in a way that lets them. Yeah, we could just stick this right here, but it will bug me if it doesn't have this little thing. There we go. Now this has enough delicate stuff on it that it is going up in a fairing, so we don't actually need the covers on our solar panels. Now if we wanted to use this for out system as well, we might put the bigger panels on, but I don't think that's really a problem here. These should get at least a little light even if these don't, or aren't deployed or whatever. We're just doing Kerbin and Mun right now, so we really shouldn't have a stupid huge amount of data to transmit, and we're also in sandbox mode, so we don't need to transmit, but if we did, we should still be okay. Okay, this rotate it. That way, okay. I don't know, I can actually just put that there. I was gonna put the lamp here, but I can just put that up there. And that's gonna make that look funny. What did I do here? That's gonna make that look funny. Yay, alright, that's acceptable. Alright, so we have probe, we have that, we don't have RCS. We don't actually need RCS on this, because we're going to have a pretty lightweight engine and throttle down. We can do RCS on its transfer stage. And we're going to, because this thing's going way in the heck out to the moon, actually no, if we do want to have the full 2 kps or so on here, then we probably do want RCS. No, we don't actually need it. Okay, yeah, we can, this is light enough that it can point pretty quickly even without it. So, this tank is probably actually enough. So one of these in vacuum. Yes. Oh yeah, that's great. So this thinks it only has 0.6, but because this is like 4 times, this actually has 2.4 in vacuum, and that will be ample. That's where that is. So yeah, this is where our gyro is, this is where our center of mass is, so this could be better, but I will declare this tolerable. Especially since we're going to have half of this gone by the time we actually need to maneuver. And we want orientation, landscape, and bigger. That looks good. So yeah, this will be, can this transmit science? Alright, we need a proper antenna too. This will be sufficient. If I put this here, it'll be glowing green the entire time. Yeah, let's check that. Cannot transmit cyan. Okay, right, it can transmit it through the antenna. It's just it can't collect science. What it was this thing here acts as like a science repository. Where did it go? Yeah, it acts as a science repository, so it can do what this thing, the lunchbox that stores all your data, can do. Yeah, so we're in space, we don't need the atmospheric thing or the air pressure thing or the only do stuff on ground thing. We have the gravity gravioli detector, the thermometer, the magnetometer, the material stuff, and the emission goo. This entire thing is like 4 tons. So getting this into orbit is going to be no problem. We should set up keybinds. You know what? I am going to dare to not be stupid and just do straight up extend. If you want to retract the antenna, you're doing it by hand. And all the science will get done by hand. It could be set up to be done automatically, but nah. Alright, so we have 4 tons of craft. That means we need about 12 tons of liquid fuel underneath it. No, it's actually more than we need. That'll get us like way in the heck out. You remember that after getting to LKO, we still had some left over in the previous one. Alright, that's right. This will 4 tons, and then we get another 8 tons from wherever. Way down here. That's way more than we need. Okay, we're going to 1.5 size then. And that's more than we need. I could even no, 3 of those is going to be too noodling. Okay. No, that would just be silly. Alright, we have 3 tons of that. Tons of that. That's more fuel than we need, but it gives us something that's not going to be ridiculously... Oh, right, we need a payload fairing. Getting that would be bad. Okay, and that means we can actually ditch that. Just use that. Not having. Okay. There we are. I think we're going to end up having less fuel than we would want on that stage, but that's acceptable. Okay, that's 5 tons. So we're going to need a full 15. Which means the 1.5 may have been kind of pointless. Yeah, especially since we can always reduce the amount. No, let's just do it. Yeah, we can get 15 even. This way it's 20 tons, and we want at least 1 gravity, so we want 0.2 meganewtons. On an engine that is... oh, I could actually do it. Yeah, if you want to put a smaller engine on that, you can use an engine plate. I think this is... I can never remember which are the 1.5 engines, as you've probably guessed from watching me try all of them. Yeah, this is the high efficiency one. Oh right, the lynx, or the cheetah. Bobcat is that size, but the bobcat is... Actually, yeah, it's... Okay, this is half the power we need, this is twice the power we need. Bobcat it is. 22 tons. Yeah, I normally ditch the fairing before engaging my second stage. Alright, that's fine. 22 tons, which means we need 88 tons. Around 90 tons of this. So 4 kickbacks, no problem. That'd be hilarious if we could just stick it on top of a thoroughbred. 2 Pollux boosters, no. Yeah, the issue with this is that this actually does need RCS to turn in orbit. Let's just do a quick check to see if I can actually do this. See, because this thing flaring out makes it difficult to hold the boosters away from it, unless I use those, that'll do. And kickbacks for those would actually probably do it. So either 4 kickbacks or 2. Yeah, let's just do those up. No, let's put that down a bit. Yeah, the Pollux would have been a pain to mount. And 2 of those. 4 of these is fine. 2.4 meganewtons. That's probably... Oh no, it includes its own weight. Helps if I line that up right. Yeah, and as soon as this goes poof, this is actually going to tip in. No, it might be okay. Okay, yeah, since that's... Alright. Before I do that, let's find out where the center of mass is. Not the center of thrust, center of mass. Some RCS, we just don't need a whole heck of a lot of RCS. This will be ample. But this is probably way more than we need. You mainly use RCS when you're docking. Down so that our center of mass is lower. Yeah, this is going to make it difficult to turn, but I really don't want to put them firing directly into the RCS tanks, just because that offends me. And I can mount a rocket bit lower, so that if the attachment point is above its center of mass, it should ping off away and this folds in. And I'm just going to hope that's good enough. That's the little nose cone. No. That's the little nose cone. Yes. Fins. Yeah, the thing is we need to actually put the launch clamps somewhere. That's in the wrong direction, isn't it? So we have to make sure there's room under these for the launch clamps, while still making sure that, yeah, the center of pressure is way behind the center of mass. There we go. That's not at all an accident waiting to happen. So that and that will go at the same time. That and that. You know, let's just move that back up there. Because we could throttle this back down and then set up, and then ditch this shell and then go on our merry way. Alright, so that should have around 2.4 kps. And I find it's a good idea just to make a note of how much delta V you have. Right then. So we have RCS for that. We have gyro, control, power, battery. Something that can be handy is putting solar panels out here if you are going to do an interplanetary transit or anything like that, with your payload still in its fairing, but that doesn't really apply here. I tend to do that when I do recoverable boosters too, but nope, these can just burn up in the atmosphere or land on someone's house. Alright, commands are already set up. I think we're good. So this is going into Kerbol polar orbit. We're going to want to use as much of the second stage's fuel as possible to get us there, because getting to polar orbit is such a pain. Or not actually, since I can just launch straight there. Yeah, that works. Normally you'd go into high orbit, then adjust your inclination while your velocity is low, and then enter polar orbit from there, and then go back into low orbit. I don't remember exactly what the science mapping orbit was with these things. I think it was anywhere from like 50 to from a couple hundred to 1,000 kilometers. So I'll just put this in a nice 100-kilometer orbit, and I will, instead of tipping west, or east rather, tip north. That should work. What am I forgetting? Yeah, because these things do not have gimbals, we want to turn RCS on. I mean, we should be stabilized just from the fins, but better safe than sorry. That wobble is not looking good. Let's just... What is RCS trying to do? Oh, I get it. Especially since when we hit orbit, we're going to be, our effective service speed is going to change. So especially when that little discontinuity happens, you do not want to be on station keeping mode. You're going to have a bad time. Okay, this is a little underpowered for our first stage, I think, but not by too much. We're okay. We're good. We actually got a little bit fast in the lower atmosphere there. Okay, apparently we're pointing south instead of north, whatever, that's fine. I don't care. Alright, so that's okay. Ditch our fairing. And let's get our periapsis above sea level, shall we? There's no reason not to deploy everything right now. Yay. We look pretty. That's what we're going for that. We want to be a little bit more that way. Yeah, we're going to be pulling this yellow marker, and we want it to pull to right there. Although I am not liking how much we were wobbling when I was doing that maneuver, so I will throttle down for turn back here. There we are. Okay, yeah, our axis is going way up. And like we should have done before, now that we are at approximately going to hit, yeah, let's just do that. Yeah, now that we are at an orbit that's just barely above sea level, and that's shortly going to be back down into sea level, we ditch our stage. And underwater. Now, anything below about 20 kilometers is supposed to burn up, but that was stupid? I really should have, okay, yes, we want to go out a little bit first. IBM. Okay, we want it to be somewhere not pointing directly at that thing. That's a good way of putting it. Now we go prograde. And in fact, we go down here. So we trade off periapsis versus... Okay, we're just going to wait for periapsis. Anyway, we should be inclination pretty much, yeah. Oh, right, because we want to be at, we want to be at 1,000 kilometers, so yeah, higher periapsis, A-okay. Sorry, apoapsis. Now let's just put it at 600 kilometers. We can do that. Thousand kilometers is my parking orbit for a couple other things. Generally, interplanetary launches, it's because you want to be burning as close to Kerbin as possible for O-berth effect to give you free delta V, but the problem with that is that if you're doing interplanetary, you're typically using a high efficiency, very low thrust setup, which means it's going to take you several passes if you're burning near Kerbin, because you're only near Kerbin for a brief time. What I will instead do is just pack a bit of extra delta V and do my burn like 1,000 kilometers away, where I'm not getting as much efficiency for delta V, but I can do it in one burn without having to do the horrible course plotting. What am I doing? Helps if I'm prograde. There we go. Close enough. And I will once again put us scan for life forms. I can even see how much battery this is using. Okay, we're charging faster than we're transmitting, so we're excellent no matter what. And now we have Kerbin's resource overlay. So if we wanted to mine Kerbin, that's where we'd do it. Now, if we were smart, we would actually have run the repeatables in low Earth or low Kerbin orbit as well, and taken one goo in low orbit and one goo in high orbit. But for now, we'll just deal with it this way. And we'll just extend that because it looks pretty. Behold, our science satellite doing science, and we should probably name it. dubbed the Ceiling Cat. And so Ceiling Cat Kerbin was placed in orbit, watching the planet below. Stay tuned for our next episode.